let's proceed to the next question. What we have in the next question? Yes, if f1 which is equal to 2x plus 2 times of iy and f2 which is equal to x square minus y square plus 2 times of ixy, then choose the correct answer. Yes, now I'm going to rewrite the question again. F1 what they have given, it is equal to 2x plus 2 times of iy and f2 which is equal to x square minus y square plus 2 times of I x y. This is what they have given, right? Now we must check whether this is analytic or not analytic. Both are analytic, either one is analytic, neither both are not analytic, right? So we shall start. What it should obey, it should obey the CR equation, or we call it as a Cauchy-Riemann equation. According to the Cauchy-Riemann equation, what we have, ux which is equal to vy and uy which is equal to minus of vx, right? This is what we have. Let us see for the first equation. For the first equation f1, we have u which is equal to 2x and v which is equal to 2 times of y. Let us proceed. That is ux which is equal to 2 and uy which is equal to 0 and vx which is equal to 0 and vy which is equal to 2, right? Now from um, the CR equation, from the f1, it obeys, that is ux which is equal to vy and uy which is equal to vx. So f1 is analytic function. Okay, let us see for the f2, then we shall tick to the options. Now for f2 function, you have u which is equal to x square minus y square and v which is equal to 2 times of xy, right? Now ux which is equal to what? A differentiation of x square minus y square with respect to x, that is it will be 2 times of x, uy which is equal to minus of 2y. Here vx which is equal to 2 times of y and vy which is equal to 2 times of x, right? Now ux we got to be equal to vy and uy we got to be equal to minus of vx, right? Both are analytic. From the solution we got that both are analytic, so option C is the right option. That is both f1 and f2 are both analytic. Yes, let us proceed to the next question. In the next question, what we have, the value of the integral, that is I which is equal to integral of 0 to 2 pi d theta divided by 5 plus 4 cos theta whole square is. Yes, this is what we have, right? Yes, let us solve this question. I am going to rewrite this question again. The I which is equal to 0 to 2 pi d theta divided by 5 plus 4 cos theta whole square. Yes, now what we must do for this question is, we are having the standard integral, that is 0 integration of 0 to 2 pi d theta plus a plus b cos theta, which is equal to 2 pi divided by square root of a square minus b square. This is the solution for the standard integral. Now what I am going to do, to this equation 1, I am going to differentiate equation 1 with respect to a. Okay, that is d divided by dA of 0 to 2 pi dA, sorry, it is d theta divided by a plus b cos theta, that is equal to d divided by dA of 2 pi divided by square root of a square minus b square, right? I'm going to continue here. After differentiation, what we are going to get, that is integral of 0 to 2 pi and d theta remains d theta only. In the denominator it will be it will goes to the upside, it will be minus 1, so it will be minus 1 a plus b cos theta to the power of 2, right? That is equal to, differentiation with respect to a is 2 pi, it will be minus 1 by 2, and a square minus b square to the power of minus 3 by 2. Again, differentiation of a square is 2a. This is what we are getting. 2 get cancels here, minus it will be plus, right? So what we are getting the solution, that is 2 pi divided by a square minus b square to the power of 3 by 2, right? Now substitute, instead of a what we have, instead of a we have 5, instead of b we have 4. So it will be 2 pi divided by uh, 2 pi, and here one more a was left here, a instead of a square it will be 5 square, minus instead of b square it will be 4 square to the power of 3 by 2. Here also substitute, if I substitute 5 it will be 10 pi divided by 5 square is 25, minus 16 it will be 9 root it will be 3 cube means it is 27. Okay, it is 10 pi divided by 27. Option B is the right answer. Yes, let us proceed to the next question. What we have in the next question, the value of the integral, that is integral of z square dz, where c is a unit circle. Yes, um yes, let us proceed to this question. This was similar to the first question that I have solved. First, we must find the poles of this integral. So the poles in the denominator, nothing is z. So z, which is equal to 0, is a pole of order 1. Next, we need to find the residue. Second step, residue is limit z tends to 0, z minus 0 into f of z. Here f of z is limit z tends to 0, z into f of z. F of z is what? Z square. So z into z square is z cube. After applying the limit, it will be 0, right? Now what is the formula? That is to find the value of the integral f of z into dz, which is equal to 2 pi I, that is sum of the residues within contour C, right? Now the sum of the residue is, we got it to be 0, because 0 z, which is equal to 0, here they have asking the unit circle, means it pole lies inside the circle only. So it will be, the value is 0, 0 into anything is 0 only. So we are getting the value to be equal to 0. So which is the right option? Option B is the right option. Yes, let us proceed to the next question. Yes, what we have in the next question, the value of the integral, that is 1 divided by pi I integration, that is closed integral over c dz divided by z square minus 1, where the contour C is a circle of radius, that is a not equal to 1, with origin as center. Origin is at center, and radius, that is a, that is not equal to 1. Okay, it is given by, yes, it is little conceptual question. Let us proceed to this question. They have given the integral, that is 1 divided by pi I closed integral over c dz, closed integral over c dz divided by z square minus 1. Now what is the first rule? First rule is we must find the what, that is pole. So denominator I am equating it to 0, so z square I am getting the value to be 1, so z, which is equal to plus or minus 1. Okay, and they are saying the radius not equal to 1. Yes, let it be the radius not equal to 1, in the sense let us find the actual integral value. Now z, which is equal to, for 1, what is the residue? Residue we will find. For a z which is equal to 1, we must find the residue, that is limit of z tends to 1, z minus 1 into f of z. F of z I can write it as z minus 1 into z plus 1, right? So it will be z minus 1, z minus 1 get cancels. After applying the limits, that is z tends to 1, it will be 1 divided by 2, the solution we are getting. Right. Now, for the residue, I'm going to find the residue for limit z tends to minus 1. Right, z tends to minus 1. Z tends to minus 1 is minus of minus, it will be plus 1 divided by z minus 1 into z plus 1. Right, get cancels, so it will be 1 divided by z minus 1, minus of minus, it will be minus 2. The value I am going to get minus of 1 divided by 2. If I found the value of this closed integral f of z into dz, which is equal to 2 pi I into half minus half. So half minus half, that is equal to 0. So what they are asking means the value is 1 if it is independent of a. The value is 1 if a greater than 1. What if a greater than 1? We did not find. If a which is equal to 1 and a less than 1. For a less than 1, the value is 1. No, the value is not 1. And for a greater than 1, there is no option to find the a greater than 1, a which is equal to 1. So our answer is obviously it is 0. The value is 0 and it is independent of a. It is not depending on a, it is independent of a and the value is 0. Okay. Yes. Let us proceed to the next question. What does the next question says? If f of z is a function of a complex variable, that is z, given by f of z which is equal to square root of z minus 1 divided by z plus 1 whole square. Options they have given: z which is equal to minus 1 is a simple pole, z which is equal to minus 1 is a branch pole, z which is equal to 1 is a branch point, z which is equal to 1 is analytic in the region. Okay, okay. Let us solve this f of z which is equal to square root of z minus 1 divided by z plus 1 whole square. Now, how to find the pole? I have thought the similar questions. It is z plus 1 whole square. I'm equating it to 0. So, z plus 1 which is equal to 0 means z which is equal to minus 1. Right, z which is equal to minus 1 of order 2. Okay, that we must keep. If order any pole, if its order is 1 means we call it as a simple pole. Okay. Now look at the options. What they are asking: z which is equal to minus 1 is a simple pole. No, it's z which is equal to minus 1. It's not a simple pole. It's a pole of order 2. Option A is wrong. And z which is equal to minus 1 is a branch point. Now we shall calculate the branch point. The branch point is calculated, and here z which is equal to minus 1, they are asking as a branch point. No, z which is equal to minus 1, it is again a pole of order 2. Okay, it won't be the branch point, I'll tell. I'm equating the numerator part, that is equal to 0. If I equate the numerator part, I'm getting z which is equal to 1, and z which is equal to 1, I'm calling it as a branch point. A branch point as a point which has more number of poles, not only a single, it will be having more number of poles. Okay, so z which is equal to 1, it's called as a branch point. Yes, this is a right option. And z which is equal to 1 is analytic. If it is a branch point, if the pole is considered to be, if this z which is equal to 1 is considered to be a branch point, means that branch point is not differentiable, neither differentiable nor analytic. Okay, so that branch point is not analytic. It is clearly the condition of the branch point. It is not analytic means they have given it to be analytic in the region. No, this is also the wrong option. Option C is the right option. That is z which is equal to 1 is a branch point. Yes. Let us proceed to the next question. What we have in the next question is, if v of x comma y which is equal to 2xy plus 3, I'm going to rewrite again, and f of z they have given u of x comma y plus iv of x comma y is analytic, and further f of z which is equal to 0, it is equal to 2 plus 3i. Then the function u of x comma y, they have given v of x comma y, we need to find the u of x comma y. This can also be found out according to the Cauchy-Riemann equations. So what we have, ux which is equal to vy and uy which is equal to minus of vx. Using these conditions I can find. Now they have given v which is equal to 2 times of xy plus 3. Now from here I find vx. Yes, vx is nothing but 2 times of y, and vy which is nothing but what, 2 times of x, right? Now what we have from this equation, ux which is equal to vy, right? Instead of ux, can I write it as vy, that value which is equal to 2x, right? Now dou u divided by dou x which is equal to 2 times of x, on cross multiplying dou u which is equal to 2 times of x into dou x, on integrating both sides it will be u which is equal to 2 times of x square divided by 2 plus so constant c. We got u value to be x square plus c. Similarly, we will find out for the next term, that is equal to uy which is equal to minus of vx, right? Instead of uy, can I write it as it is minus of 2x, minus of 2y. Here it is minus of 2y. Yes. Now dou u divided by dou y which is equal to minus of 2y, on cross multiplying and integrating. So integration of dou u which is equal to minus integration of 2 times of y into dou y. Now I'm getting u which is equal to minus of 2 times of y square divided by 2 plus c. On combining both the equation, u of x comma y which is equal to x square minus y square plus c. So which option is the right option? Option C is the right option. Instead of c, we have a constant 2 here. Yes. Let us proceed to the next question. What we have in the next question, the value of the integral dz divided by z, where c is a unit circle with origin as its center and the integration is done in a clockwise path. Okay, it is important, clockwise path is important, and it is a unit circle. Okay, so I'm going to rewrite the question again. It is closed integral of dz divided by z. First we must find the pole, equate denominator to 0. So z which is equal to 0, it is a pole of it, we call it as a simple pole or a pole of order 1. So a residue, it is nothing but limit z tends to 0, z minus 0 into f of z is 1 divided by z, z get cancelled, so we got the value to be 1. So how to find the closed integral of f of z into dz, the value which is equal to 2 pi I into 1, so it will be 2 pi I, and look at the question, they have given it as clockwise path. Clockwise path is negative, so negative of minus of 2 pi I is the right option. Yes. Let us proceed to the next question. We have the question, the value of the integral, that is 1 divided by 2 pi I integral over c z to the power of m minus n minus 1 dz, where m and n are the integer and c is a circle centered at origin. Yes, let us solve this question. I'm going to rewrite this question. It is 1 divided by 2 pi I integral over c z to the power of m minus n minus 1. So I am taking this complete term, that is m minus n minus 1 which is equal to k. Okay, if I consider k value which is equal to minus 1 means m which is equal to n, right? We shall see for m which is equal to 1 whether the integral we are getting to be 1, right? So we shall proceed. It will be 1 divided by 2 pi I integral, closed integral from m which is equal to n, the k value which is equal to minus 1, that is z to the power of k. So I can write it as 1 divided by 2 pi I integral over z to the power of k is nothing but z to the power of minus 1, right? And now how to proceed to this question means, now we have a z can be written as r into e to the power of I theta, right? Now instead of d theta, can I substitute for dz, the dz which is equal to, here we have a dz, I forgot to write, yes, differentiation with respect to z, so r into e to the power of I theta. I theta is differentiate with respect to theta, it will be I into d theta, right? So it will be dz r into I e to the power of I theta and d theta, and integration from 0 to 2 pi. So it will be 1 divided by 2 pi I integration from 0 to 2 pi. Instead of z inverse, it will be 1 divided by r e to the power of I theta. Instead of dz, it will be ri e to the power of I theta into I theta into d theta. Now r get cancels, e to the power of I theta, e to the power of I theta get cancels. So it will be 1 divided by 2 pi I integration of 0 to 2 pi. And instead of I theta, if I integrate, what I am going to get, if I integrate, it will be 1 divided by 2 pi I, it will be I into theta, substitute the limits 0 to 2 pi, so it will be 1 divided by 2 pi I and 2 pi, so 2 pi I get cancelled, so it will be what we are getting the value to be equal to 1, right? Now yes, this half of the option got corrected. If m not equal to n, let us keep the value to be equal to k itself. Okay, no need to change anything. If I keep the value to be equal to k only, I'm going to continue here, it will be 2 pi I into 0 to 2 pi, z to the power of k means r to the power of k e to the power of I theta into k, right? Instead of dz, r into I e to the power of I theta into d theta, right? On solving, 1 divided by 2 pi I, this terms I can take it outside this integration part, so it will be r to the power of 1 plus k into I integration from 0 to 2 pi e to the power of I theta 1 plus k, right, into d theta. So after doing this integration, we are going to get the value means e to the power of I theta into 1 plus k can be replaced. Okay, so you, after integration, that is e to the power of I theta into 1 plus k divided by I into 1 plus k, right? I get cancels and 1 plus k remains as it is, and after that we can substitute. After integration, we will be getting this value to be equal to 0. Okay, you can cross check, take this as a homework. This integral value, it will be equal to 0, so I can tick to this option. If m not equal to n, it will be 0, and if m which is equal to n, the integral value will be equal to 1. And it is 0, no, it is not valid option. 1 is not valid option, the conditions they should mention, and m minus n, it is not at all valid. Yes, let us proceed to the next question. What does the next question says? The fourth question, which was asked in the year 2024. What is the sum of the residues of the function, that is f of z, which is equal to e to the power of z divided by z square plus a square at all its poles? Yes, sum of the residue they are asking. What is our task? First we need to find the poles, right? Let us find the poles, z square plus a square. So poles are, we need to equate this z square plus a square, which is equal to 0, z square which is equal to minus of a square, z which is equal to plus or minus iota into a. We are getting the poles to be plus iota into a and minus iota into a. Now we need to find the residue. How to find the residue? For z which is equal to ia, limit z tends to ia, z minus ia into e to the power of z divided by z square plus a square. Z square plus a square, it will be z plus ia into z minus ia, right? I get cancelled, so we are getting e to the power of z divided by 2 times of ia. If I do it for z which is equal to minus ia, I'm going to get the solution to be equal to e to the power of z divided by 2 times of minus 2 times of ia. What they are given, the sum of the residue. The sum of the residue is e to the power of z divided by 2 times of ia minus e to the power of z divided by 2 times of ia. It will be 0. 0 they have not given in the any options. Now how to solve this problem? Think the function f of z is given in the form of phi of z and psi of z, means denominator is also a function of z, numerator is also a function of z. Now to find the residue for this function, it will be f of z which is equal to phi of z into psi prime of z. So the function phi of z is e to the power of z. Psi prime of z is z square plus a square. If I differentiate with respect to z, it will be 2 times of z. Okay. Now for this, I need to apply the residues. So if I apply the residues, what will be the solution? I am going to write here residue for z which is equal to ia which is equal to e to the power of ia divided by 2 times of ia. Okay, residue for z which is equal to minus ia which is equal to e to the power of minus ia divided by minus of 2 times of ia. Now for solving, if I solve, what I'm going to get, it will be and adding e to the power of ia divided by 2 times of ia minus e to the power of minus ia divided by 2 times of ia, taking a common in the denominator, that is 2 times of ia also I can take common, it will be e to the power of ia minus of e to the power of minus ia. This complete part I can take it as sine of a divided by a. So this can be written as sine of theta. How can we write sine theta? Sine theta is equal to e to the power of I theta minus of e to the power of minus I theta divided by 2 times of I. Similarly, instead of theta, I can write it as a. In the denominator, already we have a here. Yes. So which option is the right option? A right option is option 1. We need to use this concept. The problems like this, we must use this concept. And in the previous question, this question was also asked from 2024. In the 2024 under complex analysis, they asked a little tricky problems which was very time consuming. Okay, yes, let us proceed to the next question which was asked recently in 2025. What is the value of integral of dz divided by z? This is a repeated question. Centered, that is radius which is equal to 2, centered at the origin, and the integration is done anti-clockwise direction. Okay, this take into consideration. So first we need to find the pole. A pole, it is easy, z which is equal to 0. Now find the residue. Residue in the sense, it is limit of z tends to 0 f of z. Limit of z tends to 0 f of z means z tends to 0 into z into f of z. So it will be z into f of z is 1 divided by z. Z get cancelled, so the value will be 1. So the formula is 2 pi I into sum of the residues, it is 1. They have given the anti-clockwise direction, means the formula remains the same, no need to put the negative sign. So which option is right option? Option 4th is the right option, that is 2 pi I. Yes, I hope everyone is clear with all 13 problems that we have solved today. And complex analysis is very important topic without fail they have been asking in each and every year. So do concentrate. For more videos you can visit my channel, especially I'm concentrating to the KSET 2026 examination. So do follow my channel. Thank you for watching.